Hello everyone. In today's lecture, we are going to discuss about analog to digital converters. So before entering into analog to digital converters, let us have a small introduction for this. First, what is sensors? What are the different types of sensors? So this is the difference between an analog signal and a digital signal. These are the different sensors available, analog sensor, and this is analog to digital conversion process. Why do I show all these sensors first? See, whenever we need to analyze the data, we'll be first sensing the using a transducers or anything. Will be acquiring data acquisition will be done initially. So sensors is commonly used to capture any data. This data, what is captured through the sensors, are analog in nature. But when we give it to a processor, which, for example, if it is a digital signal processor, then it cannot operate an analog signal. So it is necessary to convert analog signal to digital signal. Right? This is the reason why we need to know about analog to digital conversion. And here if you see we have the analog sensors. That is what the sensors which I showed previously. Almost all the sensors are analog in nature and the signal what is being received from those sensors are analog. But when a controller or digital controller wants to process it, then we'll be using digital signal. So it is required to convert analog signal into digital signal. And whenever we speak about this analog to digital conversion, we'll be speaking about how much bit resolution it is. When the number of bits increases, the resolution also will increases. Similarly, when we learn about analog to digital conversion, we need to know about what is step size. Normally, the whole dynamic range of a particular signal will be splitted into different levels. So this level depends on the number of bits which we are using to, that is the resolution, number of bits which we are using to represent a particular point in the signal. So when the number of bits increases, the step size decreases, the resolution increases because the error after analog to digital conversion, the error depends on the maximum error normally will be step size by 2, that is 0.5 normally. So if the step size reduces, then the step size by 2, that is the error also will reduce. So this is the how the step size can be increased by increasing the number of levels. How the number of levels can be increased by increasing the number of bits, that is to represent a particular value. So now coming to many methods are available for analog to digital conversion. So one among that is a successive approximation circuit, which is commonly used in many applications. Right? So here we have a successive approximation register, right? And here we give the input signal to a sample and hold circuit. This sample and hold circuit normally will convert the signal to digital. So this output is given to a comparator. This comparator will compare the given input signal with a V reference signal, and this error is being given to successive approximation register. Then it is being converted to digital signal, and then this is a digital signal, right? So successive approximation register. This here what is coming inside to the comparator is analog signal. So this also has to be analog, and so a DAC is being used to convert this digital signal into analog signal. So here we have considered a V input voltage of 200 volt. So this is the value, and this is the initially SAR output will be 0, and in the next iteration a comparison is being made, right? This V in 200 is compared with the value. So initially the first MSB will be made equal to 1 in the first cycle. So After making it to 1, it's been converted, and then a comparison is made. Based on this comparison, either this output of the comparator, the SAR will change its value. So see here at different iterations we have mentioned, right? For different iterations we have mentioned, right? So based on the comparator value, whether it is 1 or 0, where either to change the next bit or the previous bit will be decided here in successive approximation circuit. So this is a general thing about analog to digital converters. So when it has been discussed with respect to in the context of PIC, we have to discuss about the registers what are involved when analog to digital converter. Right. So here we have the register which are involved in analog to digital converter, and one is add con 0 register, that is ADC on 0 register, right? So here see it is an 8-bit register, right? And here the 7th and 8th bits are used to select the clock signal. The bit number 3 to 5 is used to select the channel, right? So totally 8 channels are there, 0 to 7, 8 channels are there. Which channel we need the output can be selected. Then bit 2 is that to mention the status of the unlocked, whether it is over, whether it is completed, or those things. Suppose if add on is equal to 1, and then it means that progress, it is going on, the operation is going on. Then bit 1 is unimplemented bit or an undefined bit. Then bit 0 is add on bit, add on bit. So these are the registers available with ADC on, right? So if I want to vary a particular bit of ADC registers, then we can do it the same way as we did with the TRIS registers for calling ports, right? So this is how we can enable any single bit. So if it is ADCS, if these bits are 0 and 1, what does it mean? If these two bits are 0 and 1, then it means that the clock is oscillator clock divided by 8 is being selected. Suppose if these three are 0, 0, 0, then what does it mean? 0, 0 means if bit 3 to 5 is 0, 0, 0, then it means that analog channel 0 is selected. So this is how by varying the add control register we perform the operation. This is PIR register. So in this PIR register, if you see, this is a bit which is related with ADC which we use. So whether it's like a flag register, so whether the process analog to digital conversion process is over or not has been mentioned by the PIR register. Next is add con register, ADC on 1 register, right? That is ADC on 0 register, and this is ADC on 1 register. And here also we have few registers like the same. This is an assessment for you. References, and thank you.